Welcome to Statistics class. This is our Module 1 Introduction Review on some Parametric Test. To guide us with our presentation, we will talk about or we will discuss the overview of non-parametric test and non-parametric test. I mean the parametric test, and then we have the overview of non-parametric methods. And then we will review the levels of measurement and then review on some parametric test. So let's define data analysis. It is the process of analyzing data. So in statistical procedures used for analysis may be classified as descriptive or inferential. So we have two divisions of statistics, namely the descriptive statistics and then the inferential statistics. When we say descriptive statistic, from the word itself, describe. So it comprises those methods concerned with collecting and describing a set of data to yield meaningful information. So descriptive statistics are useful for organizing and summarizing data to provide a picture of the data. For example, we have the frequency and percentage distribution table, the correlation, and then we have the inferential statistics comprises those methods concerned with the analysis of a subset data leading to predictions or inferences about the entire set of data. In other words, you will have the set of samples and then you will have the conclusion regarding the entire set of data. So when we say inferential statistics, simply reporting descriptive statistics about a group or groups may be insufficient. So that's why we have this inferential statistics. And then it is important and necessary to examine if there are differences to the variables have differences to each other, so that we have or we will use this inferential statistics so that we can have the conclusions regarding the set of data. And then we have the overview of non-parametric and parametric statistics. But we have these two major classification of statistical procedures. We have this parametric and non-parametric. As we know, specific statistical tests are available within each category to perform various analyses. However, data for each category should meet unique requirements prior to analysis. For example, in parametric tests, there are really specific statistical analyses or statistical tests under this classification or under these procedures. And then if you cannot meet these assumptions of parametric tests, you also have specific statistical tests under this non-parametric test. So before you analyze your data, you first have to meet the assumptions of parametric or non-parametric before using such analysis under this classification of statistical procedures. So to review, as it is also in our textbook, the comparison of non-parametric and parametric tests. So I believe you already have a background about the terms that we are talking about in your elementary statistics. So when I say under the non-parametric statistics, it must be continuous distributions. However, in parametric, it's more stricter, so you really have to meet these assumptions of normality and equal variances. And then in non-parametric statistics, they use median. As we know, we have the three basic central tendency measures or location. We have the mean, median, mode. In non-parametric, they are using mostly the median as a location parameter. However, in parametric statistics, they are using mean, the variance, and standard deviation as location parameters. And both of them, the non-parametric and parametric, must have a random sample. And then independence of responses. They are the same under the parametric and non-parametric statistics. So when you say independence, my response for example, in a survey, my response in one item, I am independent of the response of the another respondents to the same or a different items in that survey. And then in non-parametric test, It uses nominal, ordinal, and then interval, and sometimes ratio. So these are the four hierarchical levels of measurement. However, in parametric, they will only use, usually the test only use the interval and ratio data or levels of measurement. And then in non-parametric, you can use non-parametric statistics or test under the statistics. You need to have these large and small data sets. It's fine. However, in parametric statistics, they really need the large data set. So a minimum of 30 or more cases. So whenever you have the samples or data lower than that, usually they resort to non-parametric tests. And then, non-parametric statistics has weaker statistical power than parametric statistics. On the other hand, in parametric statistics, it is more powerful than non-parametric tests for rejecting the null hypothesis. In other words, parametric tests are usually sensitive in rejecting the null hypothesis. So any changes in any data would lead to the rejection of your null hypothesis in your hypothesis testing. So that's the comparison about non-parametric and parametric statistics. So let's have an overview of parametric statistics. When I say parametric statistics, they are usually or often referred to as inferential because they assess parameters of a population based on statistics from a sample. So it assumes that sample data comes from a population that can be adequately modeled by a probability. So usually they are related, the parametric and inferential, because they usually, in fact, they are often referred to as inferential statistics. And then it constitutes a group of tests appropriate for analyzing interval and ratio data. As you can see in the previous slide, in the comparison of parametric tests, the data that is being used under this parametric statistics are interval and ratio. And then here's the basic assumptions of parametric test, that before using any parametric statistical tool, you must meet this assumption. Normality. If you can see in most of statistic book, you can see there a bell-shaped curve. We call it as a normal distribution. So before you use that test under that parametric test, you must meet the normality. And then the homogeneity of variance, similar spread of scores around the mean. And then randomness and independence. So as I've said, for example, in a survey, my response is independent to the response of another participant. So to review again, the parametric statistics, the normality. So it is really one assumption that the population data must be normally distributed, and the sample data from that specific population are also normally distributed. So you call it the distribution, the normal distribution has data points that fit symmetrically or in a bell-shaped curve. So that is the normality that must be met by any parametric test. And drawing a random sample from a normally distributed population also helps to meet the normality assumption. For example, measures for two independent groups may reveal similar median values, but then the mean values may be vastly different. So in such cases, the data may not be normally distributed, and a parametric procedure could yield a statistically significant result, whereas in non-parametric it can result to statistically significant. So that's why you need to meet the assumption of normality before you use a parametric test. And then, so as to to avoid misleading information or misleading results. So you must meet the assumption of the non or of a parametric test. I mean the normality, the homogeneity, and then the independence. So let's have the overview of non-parametric tests. So it can be traced to the early 1700s when Arbuthnot, a Scottish-born physician and author, used binomial probability calculations. And these are usually called as distribution-free methods. So when you say distribution-free method, it does not assume anything that the underlying distribution, for example, it must be normal distribution. So that's why it's called distribution-free methods for non-parametric tests. And then it is used when assumptions for parametric are not met. For example, you have no other choice because you have the sample size lower than 30. So instead of making your data um, or putting your data in a trash can or not, will not use it at all for your analysis. That's why the statisticians, the mathematicians, scientists, they've come up with the idea and the formulation of this non-parametric test to circumvent the issues of not meeting the assumptions of parametric test. So we have this non-parametric test. And then when a distribution is non-normal, because normality is really important in parametric test, so non-parametric statistics are considered to be more efficient. And as non-parametric procedures are insensitive to outliers since they are using median as their measure of location or as the measure of central tendency. Whereas in parametric, they are using the mean. Now, let's talk about the importance of non-parametric tests. As I've said, it is to circumvent the issue of not meeting the assumption of parametric test. So, the use of non-parametric statistics for small sample sizes is an advantage for researchers when it is difficult or impossible to gather sample sizes of 30 or more participants. So in some cases, in some sensitive situations, uncontrollable circumstances, sometimes you cannot have the sample size of more than 30 participants. So you will use the non-parametric methods or non-parametric tests and is for analysis of rank or ordered data, especially in the survey which are Likert scaled. So that's how important non-parametric is. Instead of dropping and forgetting your data because it does not meet the assumptions of parametric tests or parametric methods, so you could resort to non-parametric methods to give essence, to give meaning, to make use of your limited data sets. Now, let's review the levels of measurement. You have already learned this in your elementary statistics, but for us to review, let's be reminded with this NOIR. It stands for nominal, interval, ordinal interval, and then ratio. Note that the type of statistical analysis that is appropriate for a particular variable depends on its level of measurement. As I've said earlier in the previous slides, that there are specific tests under parametric and non-parametric tests. And under those tests, they require a specific level of measurement. So if they need interval and ratio, so you can use parametric test. If you cannot provide that data, then you should resort to non-parametric test. So you have to be careful of what level of measurement your data is in order for you to have the appropriate statistical analysis so as to avoid misleading conclusions, misleading information, or misleading analysis or results of your study. So this nominal, interval, ordinal interval, and then ratio level of measurement. So Let's review what is this nominal. When you say nominal level, it is used to differentiate classes or categories for purely classification or identification purposes. For example, your names, labels, categories, your gender, your year level. So that is your category, that is nominal level of measurement. So when you say male and female, that is a category. First year, second year, third year, fourth year, that is your levels. Are we of the world or of God? Are you worldly or godly? That is also a category. So that is under the nominal level. And frequencies or counts of observations belonging to the same category can be obtained. For example, I can count how many females are there in first year, how many males are there in second year. So it is possible that you can count the observations, and it is the lowest level of measurement. So you have to remember the characteristics of the nominal. So it is mutually exclusive and exhaustive. When I say mutually exclusive, it is a property of a set of categories such that an individual or object is included in only one category. If I am a female, I can only be in a female category only. So it's only one, mutually exclusive. If I'm already in that group, you cannot find me in the another group. So in only one category, that is mutually exclusive. And then when you say exhaustive, it is a property of a set of categories such that each individual or object must appear in a category. So when I say the category is gender, I must be either in a male or in a female category. So that is the characteristics of a nominal. It is mutually exclusive and exhaustive. Again, by definition, we can count this observation. So anything, a category that if your type of diet, are you a vegetarian or not, that's also a nominal level. That's also a category. Your religious affiliation, are you Seventh-day Adventist? Are you non-Adventist? That's also a nominal level. That is a category. So that is the nominal level of measurement. Let's proceed to ordinal. So from the word itself, ordinal, order. So an ordinal scale is useful for ranking qualitative variables. So for example, the students complete assignments, athletes finish a competition. So first, second, third, fourth. So it is used in ranking your student class designation, first year, second year, third year, fourth year. So that is ordinal. And then students' grades, are you excellent or not? And then faculty rank, school level, or year level, and data collected are labels with implied ordering. For example, you have in a category of first year, but there is a sort, it implies order. That means its second year is higher than first year. And then the difference between the two data label is meaningless. So that is the ordinal level of measurement. Let's proceed to interval. So it is used to classify, order, and differentiate between classes or categories in terms of degree of difference, either discrete or continuous. When I say discrete, it's whole number, continuous, it's infinite. So I believe you know this definition in your elementary statistics. So I won't bother to define it. And then data can be ordered or ranked. So the difference between these two data values is meaningful. So data at this level may lack an absolute 0 point. So that is the interval 0 to 50, 60 to 100. So that is the interval. And then we have this ratio. Data have all the properties of the interval scale. And the number 0 indicates the absence of the characteristics being measured. For example, if I say I have 0 allowance today, that means the 0 indicates a real meaning I have no money at all. So that is the ratio level of measurement, and it is the highest level of measurement. So let's have a review or a summary. When I say nominal, it indicates distinction because it is in categorical form. And then ordinal indicates distinction, and at the same time, it has a direction because it is rank or ordered. And then interval, it also indicates distinction, it also indicates direction, and then it also indicates the amount of distinction. However, the highest level of measurement is the ratio. It indicates distinction, it indicates direction of the distinction, indicates the amount of distinction, and at the same time, it indicates an absolute zero. The zero response really indicates absolute, or there is no presence of that characteristic. So that is the four level of measurement. Remember, you have to be careful to know the level of measurement of your data so as you could use appropriate statistical test in analyzing your study or analyzing your data. So to review some parametric tests, the common is t-test. So I believe you have learned this in your elementary and probability statistics. And then analysis of variance, the persons are correlation analysis, and then the regression analysis. So to review, t-test, the t-test is a basic test that is limited to two groups. For example, if you would like to compare two groups, so for multiple groups, you would have to compare each group of pairs. So, and then the basic principle is to test the null hypothesis that means of the two groups are equal. And then there are two main types of t-test. You have the independent measures and then the match or paired t-test. So, for example, independent, the group is not related to the other group. However, in pair, they are related. For example, you have conducted a survey today, and then you have asked me again tomorrow, so that is paired. And the other day, I mean, so that is paired t-test. So when samples appear in pairs, for example, before and after. So when I say the example for independent measures, for example, you would compare the academic performance between the male and the female. So they are two separate groups. And then a single sample t-test compares a sample against a known figure. So, for example, in the Bible, in using t-test, that in diet recorded in Daniel 1, chapter 1 verses 11 to 1 to 20. So we can see there in that text the independent variable, the type of diet. When you say type of diet, it is a nominal level of measurement because it is category. So what are the type of diet? We have the vegetarian and then the king's delicacies. And then what is the dependent variable? What is the response variable that we are measuring? According to Daniel, they measure the physical appearance, the knowledge and skill in all literature. So when you will use t-test, you would ask, is there a significant difference on the skills or on the knowledge of people with different type of diet? For example, does the vegetarian really is more smarter than those who have a type of diet which eat the king's delicacies? So at that example, you can compare it's two independent group, the vegetarian and then in the king's delicacies, I would compare their physical appearance, their knowledge and skill in all literature. So in that case, you can use t-test. And then for analysis of variance. So a statistical test for detecting differences in group means when there is one parametric dependent variable and one or more independent variables. So in t-test, you only have two groups to compare. However, whereas in analysis of variance, you could compare three or more. For example, is there a significant difference on the academic performance of first year, second year, third year, fourth year? So it's more than two groups. So I can use the analysis of variance. And then the person arc correlation. So to review, it is the person product moment correlation coefficient, and it is the most widely used correlation coefficient. It summarizes the relationship between two variables that have a straight line or linear relationship with each other, and the values ranges from -1 to +1, with values close to 0 signifying little relationship between the two variables. So that is our formula here projected on the screen. When you want to discover if there are relationship between the two variables. For example, is there a correlation on age and height of the people in the Bible times? Does the older people more taller than the younger one? So if you want to confirm that. And then another example or another question, is there a correlation on number of servants and the number of sheep owned by the people in the Bible times? As we know, the more the sheep increases, the more likely the owner would hire servants. So if you want to compare, you could study this. Is there a correlation in the number of servants and the number of sheep? Take note that the level of measurement is a ratio. Okay, so it's about number. And it is a quantitative variable because I'm talking about numbers. And then, before we end, I would like to give this text to you in Proverbs 3:5-6. Trust in the Lord with all your heart, on your own intelligence rely not. In all your ways be mindful of Him, and He will make straight your path. There are times, no matter how good we think we are in dealing and analyzing our data, we should not rely on ourselves or our own intelligence, and we should always trust the Lord in our analysis, not just in our schooling, not just in our studies, not just in analyzing our situation, but also about our relationship with others, about relationship to God. And in all your ways, let's always think about God so that He can make straight paths, a linear relationship with God. So Proverbs 3:5-6, always trust in the Lord and don't rely on your intelligence. So thank you and God bless you. See you in module 2.